You know how to find the center of a circle and how to find the radius. Now we're going to do a little more with that information. Today we're going to determine if a given point lies within, outside of, or on a circle, given the standard equation of a circle. As a reminder, there are two main parts of a circle included in the standard equation. There's the center point, and there's the radius. The equation of a circle is x minus h quantity squared plus y minus k quantity squared equals radius squared. Again, the center is k because that is a constant number that you will know, and the radius, which is a constant number that you will know. What changes is the point on the circle. Remember that the x and y are going to stay a variable because it depends on where you land on the circle as to what that coordinate is. But again, today we're going to talk about if I give you a point, is it going to be one of the points that lie on the circle, or is it going to lie somewhere else? So how do you decide if a point lies within, outside of, or on the circle? Well, it's the distance from the center. We know that if our point in question lies on the circle, the distance between the 2 points should be exactly the distance of the radius. But what happens if it lands outside the circle? If it lands outside the circle, then the distance from the center to our questionable point is going to be the radius and more. So it's going to end up being more than the length of the radius. And what if our point in question is inside the circle? Then the distance from the center to the point doesn't even make it to the radius. So as in summary, if the length to the point from the center to our mystery point, so C is the center, P is our mystery point, if the length of that segment is less than the radius, then the point is inside the circle. If the distance from the center to our mystery point is greater than the radius, then the point is outside the circle. And if the length from the center point to the mystery point is exactly the radius, then it's sitting on the circle, because the radius tells me where the circle is. So we're going to compare distances to determine if it's inside, outside, or on. So the way your question looks is it says, given a circle with the equation x minus 3 quantity squared plus y plus 4 quantity squared equals 25, determine if each point is on the circle, in its interior, or in its exterior. So the way you'll answer this after you show your work is you'll use the words on, interior, or exterior. So we're just going to kind of summarize the answer. So again, remember this is going to be a comparison of distances. So I am going to do the distance formula after I kind of clear up some stuff. So the first thing is, what is the center of this circle? Because I have to know what I'm comparing it to. So the center of this circle is 3, negative 4. Remember, it should be x minus h, so there's already a minus sign, so h is 3. Should be y minus, but the minus sign is gone, so 4 has to be negative. The other thing I need to know is what is the radius of the given equation, or the given circle. So remember, we're going to square root 25, so my radius is 5. So for every one of these questions, I need to know that my center is 3, negative 4, and my radius is 5. So remember, we're trying to figure out how far it is from the center to the point and compare it to the radius. So I'm going to go from point A to point C using the distance formula. I want to compare the distances. Okay. So what are my points? My points are 3, negative 4, and negative 1, 2. So I've got negative 1 minus 3 quantity squared plus 2 minus a negative 4. So 2 plus 4 quantity squared equals the square root of negative 4 squared plus 6 squared. So I get the square root of 16 plus 36, which is equal to the square root of 52. So that's about 7.21 when I find it on my calculator. So I need to compare this distance to 5. 7.21 is greater than 5. So that means I went all the way across the radius and then I went on outside the circle. So my answer is outside. That's an awful lot of work. Is there an easier way to do this? Yes, there is. Think about how you came up with the equation of a circle. You used the distance formula. So the equation of a circle is pretty much the distance formula in disguise. So how can we use that to our benefit? Well, notice this first part right here looks like this first part here. I've replaced the negative 1. Second part, the y minus k, same thing, except I've replaced it with a 2 because that was the point they gave me. So the easier way really to have done this is use the equation they gave you and ask, is the point in question really going to satisfy the equation? It's kind of a question. Will it satisfy it? Because if it does satisfy it, then it's on the circle. So we get negative 4 squared plus 6 squared equals 25. And again, it's oh, sorry about that. Hold on. Let me move that up. Okay. So I've plugged in negative 1 and 2 just like I did up here. But instead of not knowing the answer, I want it to be 25 because that's what the equation of the circle says. Okay. So now I have 16 plus 36. I'm running out of space. Again, it's still it's a question the whole time. So then I end up with 52. Well, 52 is definitely not equal to 25. So we know it's definitely not on the circle. It's greater than. Anytime you come up with a greater than, you are looking for the outside. So you can either use the distance formula, because that's really what the theorem says, that it's the distances that you're comparing, or you can use the shortcut because we know the equation of a circle is just a form of the distance formula. Okay, so let's look at that one more time. We're going to take the equation of the circle and we're going to plug in the points they gave us. So I'm going to write it just so we see it nice and clearly here for a moment. Okay, so here's the equation of the circle. If the point they gave me satisfies this equation, then it will be on. Otherwise, it's going to be interior or exterior. And I messed up question number 1. I even told you what you were supposed to do. Outside should be exterior. Sorry about that. Okay. So x is 6 minus 3 squared plus y is 0 plus 4 squared equals 25. It's not a statement, it's a question. 3 squared plus 4 squared equals 25. Or does it? 9 plus 16 equals 25. Or does it? So 9 plus 16 is 25, and that's what we were trying to get to. We were trying to get to a 25. So yeah, it works. Yes, it satisfies the equation. So yes, you are sitting on the circle because you have satisfied the equation of the circle. Okay, so let's try that one more time. So I'm going to not write down the equation just to kind of save some time a little bit here. So x is 3, the equation says minus 3 squared plus y is negative 4 plus 4 squared, that's what the equation says, equals 25. And again, it's a question. Is it working or is it not working? So 3 minus 3 is 0 squared plus negative 4 plus 4 is 0 squared equals 25. Well, that's a whole bunch of 0. 0 is less than 25. So if the number we get is less than 25, then if you were to actually find the radius, the square roots, it'd still be less than. So less than makes it interior. So greater than makes it exterior, equal makes it on, and less than makes it interior. So you can either plug it into the distance formula and compare it to the radius, which you would have had to find first, or just take the point, plug it into the equation, and determine if it satisfies it. If it satisfies it, it's on. If it doesn't, then it's either greater than exterior, less than interior.